All right, hey guys, here's the practice problem for you. Find the extreme of f of x equals x plus square root of 4 minus x squared on negative 1.5 to 1.5. Um, you should be able to do this without your calculator. The numbers are pretty nice, even though they don't look nice, and the problem doesn't look nice. It's something that does work out well for you. So let's take a look at this. Extrema means just find the max and mins on this interval, and whenever you're given an interval like this, remember you have to check the endpoints, so make a note of it if you need to. Okay, because those could be maxes or mins. So let's find the derivative first, because we got to find the critical points. So y prime is first times the derivative of the second, then the chain rule, plus the second times the derivative of the first. And then we'll do some simplifying here. And so I cancel the 2's, and I get negative x squared over the square root of 4 minus x squared plus square root of 4 minus x squared over 1. And like we've done in the past with the derivative, let's get this one fraction so that I can, it makes it easier to set equal to 0, times 4 minus x squared, or square root of 4 minus x squared rather. So then this becomes negative x squared plus 4 minus x squared over the square root of 4 minus x squared. So that's 4 minus 2x squared on the top, 4 minus x squared on the bottom, and I'm going to set that equal to 0 to find the critical values. At least some of them, maybe all of them, we'll see. So that equals 0 when the numerator's 0. Notice I don't have to worry about when the denominator is 0, because when the denominator is 0, I'm going to actually notice this up here and just say this note. 4 minus x squared is always going to be bigger than or equal to 0 because it's under the radical, right? Now, when this is undefined, that's when the denominator is 0. So 4 minus x squared, when that's equal to 0, that means x is equal to 2 or negative 2. But that's not inside my domain. So this is never going to be 0. So I'll just say note. 4 minus x squared is always positive. Does that make sense? Because it's never 0 because it's not in my domain. And it's always positive because the radical has to be positive in my original domain as well. Okay, so that's equal to 0. That means 4 minus 2x squared must be 0, which means x squared must be 2, which means x must be plus or minus, the square root of 2. Okay, so those are my critical values. Those are my possible min, max, or extrema. Okay, so let's check it out, see what we can come up with. Square root of 2, negative square root of 2, plus or minus there. So I'm going to look at y prime just to the left of square root of 2. And I remember square root of 2 is about, I believe it's 1.4 or thereabouts. So pick a number just to the left of that. Well, if you just kind of reason your way through this here, here's my derivative. If I plug in square root of 2, that's going to give me, I'm looking up here in the derivative in this box here, 4 minus 2 squared is 4, or square root of 2 squared is 2 times 2 is 4, so that gives me my 0, of course. But if you pick a number slightly bigger than square root of 2, negative, like negative square root of 2.1, then that's going to be 2.1 times 2 is slightly bigger than 4, so 4 minus a number bigger than 4 is negative. And the denominator is always positive because it's square root. So this will be negative or decreasing. I like to write decreasing, that just helps me not make a mistake. Pick a number between the two, like 0, Well, that's positive. Increasing a number bigger than 2. Square root of 2 like square root of 2.1, which is same reasoning before. It's going to make that negative. So it's decreasing. Okay, make sure that that makes sense to you how I got this negative. Okay, so now comes the communication piece. Since y prime changes from negative to positive at x equals negative square root of 2, comma, this point, negative square root of 2, comma, what's the y value? How do you figure out the y value? You plug it into the original function, and you get square root of 2 times 4 minus square root of 4 minus 2 is square root of 2, so you get 2. Actually, negative 2 is a relative minimum. I might end up changing that to absolute minimum. I don't know, but for sure it's a relative minimum. And I'm going to say this. Actually, I'm going to come back up here so I can keep it all on the same screen. Since y prime changes from positive to negative at x equal 2, the point 2, square root of 2, comma 2, that's the y value, is a relative max. Okay, so we're good there. And then now I got to check my endpoints, because those could be extrema as well. And I want to look at what about f of negative 1.5, and if I plug that in, actually I said earlier you don't need a calculator, you do to get the decimal equivalent for this, so you would need a calculator on this one. So you get negative 3.597, and notice, well, let's do them both. F of 1.5 is positive 3.597. First of all, notice 3 decimal places on both. You got to do that. But also notice 3.597 is lower than this guy. So that's going to make that an absolute minimum. And 3.597 is greater than that, so that's going to make that an absolute maximum. Why doesn't it go any higher than this value? Because if it did, then we would see it would have shown up as a critical value somewhere in here, which it didn't. Okay, so since negative 3.597 is less than negative 2, this point negative 1.5, negative 3.597 is the absolute minimum. Since 3.597 is greater than 2, the point 1.5, 3.597 is the absolute max. Okay, that's what you need to have. So then I figured out so point-wise, I took the derivative, I figured out the critical values, I communicated why they're maxes or mins, I checked the endpoints and explained why they're max or mins. And so there you have it. Okay, so you're good to go.